All right, guys, we're talking about infinite limits or limits as you go to infinity. They're two different things. Limits as you go to infinity, you've done before. That's just end behavior. We did that early in the year with like rational functions. So we'll look at that again. And then we're also doing as you approach an asymptote. What is the limit? Okay. So let's look at this first graph here. F of x equals 1 over x minus 1. I've given you the graph. Oh, you don't want the one with the answers. Hold on. Get rid of those answers. One moment here, guys. All right, guys, so let's look at this first graph. So as we approach 1 from the left, do you guys see how there's an asymptote at 1? And like, do you understand that there would be 1 from that rational graph? Does that make sense? Okay. So as we come from the left, where is this graph going? Yeah, down to negative infinity, right? So that's what your limit is. You're just going to say negative infinity. What about letter B as we come from the right? Positive infinity. Okay, and then your overall limit, did the two, yeah, do they run into each other? No, so that's just dne. Okay. So let's look at the second graph. The graph looks a little different this time. You still have that vertical asymptote at 1. So from the left, where's it going? Positive infinity. What about from the right? Positive infinity. And do the two match? Yes. You can say positive infinity.
Wait, that's like saying even if there's a hole,
still... Exactly. Yeah, the left and the right were the same thing, so you can say that answer for the overall limit. Yep. Does that make sense? With me there? Okay. All right, guys. So limits that result in infinity or negative infinity, what are they telling us about a function? They're telling us that the y values are unbounded. Or you can think of it as they are getting large in absolute value, which is a weird way to think about it. Okay, let's keep going. Notes like look long in the packet, but they're not actually that long today. We moved through them pretty quickly. Okay. These vertical asymptotes that we just saw in the graph, we need to be able to find those algebraically as well. So let's just review finding vertical asymptotes with these functions. All right, guys, letter A, does that numerator factor? It does not, okay. Denominator does. Hey guys, up here. What does it factor into? Okay. Nothing cancels out, so we have 2 vertical asymptotes. So your vertical asymptotes are at x equals positive and negative 1. You guys remember doing this with rationals? Okay. All right, you try letter B for me. Check with your neighbor. We only get one vertical asymptote this time. Where is it? -2. Yeah, x equals -2. Okay. Once they cancel, remember that creates a hole. Now, what we're left with is the vertical asymptote. Okay. We're going to keep finding limits, but I'm not going to give you the graph this time. So you could technically draw the rational graph and evaluate it that way. That's definitely one way to do it. You could think about what this looks like. We can also do it algebraically. We do need to think about the limit as x approaches 1 from the left and the limit as x approaches 1 from the right so that we can evaluate this overall limit. So algebraically, the way we can do this 1 from the left and 1 from the right is we plug in 1, so we'd get 2 over 1 minus 1, right? Which we know is 2 over 0. But we think about that 0 being from the left because we plugged in 1 from the left. So do you think that's going to create positive or negative infinity? Negative. The little it's like you're adding a negative to it when you're saying from the left. Okay? So this one is negative infinity. So let's go through that with 1 from the right as well. So again, we have our function. I plug in 1 from the right. I still get 0 in the denominator, but it's 0 from the right. What do you think that's going to equal? Positive infinity, okay? Now, again, you could sketch the graph and think about like, okay, there's my vertical asymptote and I know the shape. Like, you can certainly think through that little rational graph shape if you want to and think about which direction it's going. This is just kind of a plug-in way if it's a more complicated graph. So, since the left and right did not match, what would you say for the overall limit? Yep, does not exist. Okay, I know that's kind of weird. What questions do you guys have? Are we like, we get it, we just don't really like it? Yeah.
There's always a single point without turning off the brain.
Like plugging it in from the left and right, that it'll, yes. Now, if like the 2 had been negative in the numerator, then you'd have -2 over 0 from the left. That's actually going to make positive infinity. Okay. Yeah. It's like you're giving this positive or negative sign to the whole fraction, whatever else is already there. Okay. All right. Let's try letter B. So we should try to factor this first, which I'll go to the right. There's not a ton of room here. And guys, we don't really need laptops right now. So numerator would factor into x minus 3. Hey, Ellie, you want to grab one of those? Thanks. And x minus 1. And then your denominator would be x minus 3 and x plus 5. So we are really looking at the limit as x approaches 3 of x minus 1 over x plus 5. We factored this out. We know we have a hole there. But is this a tricky one to evaluate now? Like, do I have to be plugging in zeros from the right and left and thinking about asymptotes? Or can I just plug in the 3 into what's left? Plug in the 3 to what's left. So I get 2 over 8. It's just 1/4. Okay? So don't forget that plugging in is kind of the goal you're trying to get to. sometimes you have to do some work first, but. Okay. 4a, I'm only asking you as x approaches 2 from the right. So let's plug that in. So 2 minus 5 over 2 minus 2. So I get negative 3 over 0 from which way? Yep, little plus. So we know it's going to be an infinity or negative infinity because of that 0 in the denominator. That's our asymptote. Do you think it's negative infinity or positive infinity?
I mean, if it was a negative.
Yeah, you just look at the sign of the overall fraction. Since it's negative 3, it is negative infinity for the answer. Does that make sense? Is it a little better? Try B for me and let's see how we're doing. All right, guys, I'll go through it here. Did you guys get negative infinity?
Wait, how's it negative?
So did you get positive 1 in the numerator?
Yes.
And then it's 0 from the left, so like negative. That creates like a negative sign in your fraction.
Well, I thought it was that, like, the sign of the numerator.
No, so that, let's go back up to this 3a. Do you see how this was? These are both positive 2 over 0, but this one's from the left and this one's from the right. So this creates negative infinity.
Okay.
This creates positive infinity.
And
But then here, because we already had a negative 3, and it's from the right, the overall fraction, you can just think is negative infinity that we're
So
talking
only
about.
if it's negative numerator, then you can assume that it's a negative number.
No, if it's positive in the numerator, but you're coming from the left for the asymptote. Because what this is, it's tricky, I know. Like this 2 over x minus 1, that first one we were looking at in example 3. If I actually graphed that, it's got a vertical asymptote at 1. And then I know the shape of my rational looks like this. So do you see how from the left is going down and from the right is going up in this case?
How can you just, like, tell that?
So I know from graphing rationals, you're good with where the vertical asymptote is, right? You're good with where the vertical asymptote is?
Yeah.
Okay. And then it's bottom heavy, so I know it's got that horizontal asymptote at 0. You can think through plugging in a point if you want. Like if I plug in 2, I get 2 over 1. So I know like that's up here. So I know this is the section that that graph is going to be in. I could also plug in 0.
When would so like that's like kind of the standard form where they both go like this way.
Yeah, that's like the standard parent graph of a rational.
When do you know when it's flipped this way?
If there's a negative.
A negative in front.
Yeah,
Or
because think about, like, think with transformations. So that
when
means
do you know
flipping.
if it's like both on top?
If something is squared.
It's
Yes. Yes.
Could they ever be both on the bottom?
If it's squared and a negative. Good times, yes.
So that's basically there's just like one negative sign in the numerator, the denominator.
Yes. Yeah, you're really just counting negatives. Like this one had a negative and a positive, that's 1, so it's negative. Here we had a positive and a negative, that's 1, so it's negative.
And if it was negative,
it would be positive, yes. Yeah. Here we go. Sorry, I'm not looking at 3B, I was looking at 4B. Okay, go ahead. So I didn't have to on this one because I can just plug in the 3. So I don't actually need to do that one from the right and from the left. Well, that would give me 0 in the denominator, so that's why we have to think about from the left and from the right. This does not give me 0 in the denominator, as long as I simplify first.
As long as it doesn't leave 0 in the denominator, you don't have to.
Yeah, you can just go plug it in. This is the answer. Yes. Good questions, guys. Please ask these things because I know this is a little different, and I want to make sure you're like understanding each step as we go. Okay. Which of these have a vertical asymptote based on what the limit is telling us? There could be more than one. Talk to each other, sort it out. Let's see how we do. All right, guys. Do you think A is one with a vertical asymptote? No. What about B? Yes. What about C? Yes. What about D? Okay, good. Anybody questions on those? You seem very, very sure of that. It's not hard. If it's approaching a vertical asymptote, it's going to be infinity or negative infinity, so that's what you're looking for there, okay? And the end one is talking about end behavior, x approaching infinity, so that's not going to be a vertical asymptote. Okay, let's keep going. All right, I've given you this function. I tell you b is not 0, it's just some number. We want to find the value of b so that this has exactly 1 vertical asymptote. Then we're going to find the value of b so that this has 2 vertical asymptotes. And then the third one I think is the trickiest, find b so that it has no vertical asymptotes. So I'm going to give you some time to mess around with this, talk to each other. You're going to want to do some factoring, thinking things through. There's a couple of answers for A and B.
So just anything that doesn't so because
I don't know.
William, you're thinking good things over there.
Then you split the flows. Oh yeah, We'll never be able to wear this past month. I know you went to Madison. Oh, the hack is. Yeah, I might just stop.
All right, guys, let's see how we did. This numerator factors into x plus 5 and x minus 4. So to have exactly one vertical asymptote, you need your denominator to cancel out one of those factors. So you could either have this be like x plus 5, x minus 5. Do you see how that would give you one vertical asymptote? Or if your denominator was x plus 4, x minus 4. So B could be 25 or it could be 16. Are you with me? Yeah, makes sense? Okay. So for it to have two vertical asymptotes, you need nothing to cancel. So B could really be a lot of things here, like let's say B is 9. Do you see how that would give you two vertical asymptotes, 3 and negative 3? Yeah, you could pick nearly anything but 25 and 16. Okay? Okay, C, find B so that it has no vertical asymptotes. Did anybody figure out what B should be? No, because then you'd have a vertical asymptote at 0. Well, so you'd have x squared minus x squared, so you'd have 0 in your denominator? No. It's interesting. But no. Anybody, any other thoughts? Uh, 8? Well, if it was x squared minus 8, you could still do that. That'd be x minus 2 root 2, x plus 2 root 2. It would be irrational. but it's still a thing that would show up on your graph.
No, $40.
How do I make it so that it would be imaginary if I tried to solve it? Yeah, a negative number. What if b is, let's say, negative 9? Then I get x squared plus 9 in my denominator. Does that factor? No, because it's not difference of squares, okay? Did you guys get there? Yes, okay. So b could be any negative number. It doesn't have to be 9. It just needs to be a negative number. Okay. We are actually going to jump around because we haven't done all of the continuity stuff yet. So let's skip and just go to our 5th example here. Okay. So I know we're skipping over to what says example 2. We are now talking about something different. What do you notice that is different in this problem here? Yeah, do you see we're now talking about x approaching infinity? We're not talking about x approaching a vertical asymptote. Like it's not x approaches 3 or 4, anything like that. We are talking about the end behavior of the graph, okay? End behavior. So we did this when we did graphing rationals. Do you guys remember the whole top heavy, bottom heavy equal? Okay, that's what you're going to think about again here. When you're evaluating as x approaches infinity or negative infinity, we don't worry about anything that is smaller than the highest degree term. Because if you're essentially plugging in infinity, infinity squared is going to be way more important than just 5 times infinity, okay? So we don't even have to pay attention to the minus 5x or the 7. This is what we are thinking about. So if I look at just 3x squared over 2x squared, if you remember from rationals, this is the same degree. What did that tell us our horizontal asymptote was? 0 is when it's bottom heavy. Slant asymptote is when it's top heavy. What is it when it's equal? Coefficients. Yeah, because really what's happening here is I'm canceling out these x squareds in there. We got there eventually. You're thinking about 3x squared over 2x squared. Those are going to cancel, and so your answer is just 3 over 2. You can also think of it, if you don't want to cancel it out there, plug in the infinity. So 3 infinity squared over 2 infinity squared. Do you see there how the infinity squareds will cancel out? Like if that makes more sense to you, do that. And you're left with 3 halves. Okay. So this don't sweat the small stuff, that's talking about you don't have to worry about the constants or the things that are not the highest degree. Okay, just ignore them completely. All right, you guys try A, B, and C here. Let's see how we do on those. Yep, try A, B, and C on basically do example 3. All right, guys, letter A. We should be thinking about only this x squared over 5x squared. So what did you guys get when you plugged in? 1/5. Yes. Okay. Letter B, you needed to multiply a little, right? Like you need this negative 3x times 2x to get the highest degree. So that would be negative 6x squared over 3x squared. Did you guys get negative 2 for this one? Yes? You got 2? Do you see it? Okay. What about the last one? 0. Yes, bottom heavy, always 0. Okay, good so far? All right. This next one, example 4, this is top heavy. We did it before with rationals where you did like longer synthetic division, and we can make it even simpler. Let's just look at the only parts we care about, 2x squared over 3x. I can reduce that, so I'm really thinking limit as x approaches infinity of 2x over 3. If I plug infinity into that, I get 2/3 times infinity. What do you think that is? Infinity. 2/3 times infinity, still infinity, right? Still very, very big. Because what you're doing here is finding the slant asymptote. That is the slope of your slant asymptote, this 2/3 in front of the x. So you know as we're going towards infinity, this is approaching infinity. If you had ended up with a negative somewhere in that fraction, and x approaches infinity, you'd be a negative infinity, okay? If you're plugging in negative infinity, then we have to think a little more about what that means sign-wise. What about letter B here? So limit as x approaches infinity. What do I care about in the numerator? What is the term I'm going to care about? 9x squared, yeah. And in the denominator, negative 5x squared. So what do I get? Negative 9/5, yes. Okay, we're skipping C. We're skipping the box. Let's try to do some more limits down here. We're jumping down to example 5. Okay, same idea here with letter A, but now x is approaching negative infinity. So it is top heavy. Think about what that's going to mean. Try for me. Let's do just A and B. I want to walk through some of these others with you. Bless you. All right, guys, letter A. What did you guys come up with? That one is negative infinity. Okay, same problem as the one we were doing before, but this time x approaches negative infinity. So when you plug that in, you do get negative infinity. Are we okay on that? Okay, got to pay attention to the tiny little negatives in these limit problems.
Wait, where's the negative?
In the original,
It says it.
yeah, because it's x approaches negative infinity. All right, letter B, also a negative infinity. Numerator would be 16x squared over 8x squared. Doesn't actually matter that it's negative infinity this time. Did you guys get just 2 for that one? Yes, okay. All right, letter C. Little trickier now when we throw square roots in, because you have to pay attention to your signs a little more. So we still only care about this highest degree here. So what is the square root of 4x squared? 2x. Now, I don't know if you remember, you did this a lot in Algebra 2, that you had to put absolute value around x when you brought that out of a square root if it was an odd degree. Do you vaguely remember this somewhere? Yeah. We have to think about that now. It's okay. And then your denominator is 7x. When this is positive infinity, it doesn't really matter if you have the absolute value or not, because you're essentially plugging in positive infinities and they'll cancel out. This is just positive 2 sevenths. When it's negative infinity, though, it definitely matters. We've got to think about it. Are you guys okay with just getting 2 sevenths for this one? You see it? Okay, D has E in it. I know you are not going to like this one. Okay, we have x to the 99th, and we have e to the x. We have to figure out essentially which is stronger, which will like overpower the other one. What do you think is going to grow the fastest towards infinity? X to the 99th or e to the x? E to the x is the right answer. Exponential, meaning the variable is in the exponent. This is more powerful, okay? It like overtakes the other one. So what you really end up with here when you plug infinity is some number over, let's think about what would e to the infinity be? Infinity, like a really big number, right? When you have some number divided by a huge number, what are we actually getting close to? 0, yes, okay, good. It's a lot of weird abstract, like this is growing faster than this part, that makes your fraction bigger or smaller. Like that's what you have to think about. Is the denominator bigger or is the numerator bigger? That's what you have to think through. Okay. E also a little weird. Let's look at this one. Actually, I don't even need a limit anymore. So we're going to keep all the pieces here because let's look at what happens when we plug in negative infinity. It looks crazy, I know. When I have any number raised to negative infinity, let's think about that. Negative makes it a fraction, and then it's growing really big, like the denominator's growing really big. So this is like 1 over 2 to the infinity. What is that actually? 0. Okay? Because you flip it, and then the denominator gets humongous, because it's 2 to the infinity. 1 over 2 to the infinity. This is 0. What does this become? It's also 2 to the negative infinity. So what is that term right there going to be?
0.
Also 0. So you end up with just 4 over negative 3. These are called tricky limits, the ones we're doing in this part of it, okay? It's much more abstract, and you have to think through what this means. So 2 to the negative infinity, that's 1 over 2 to the infinity. That's 1 over huge number. Kian, you want to grab a pack here? Right? Do you see how that becomes 0?
Wouldn't it just flip the denominator as well?
No, this individual term, so I don't have enough room. Let me get rid of this. So this is like 4 plus 1 over huge. 1 over huge minus 3. You can't flip until you've like combined denominators, and we're not going to combine denominators because we don't need to. Because 1 over huge is really 0. Think about it. 1 over huge.
Yeah, so it'd just be 4.
Right, 0. Yeah. So it's just 4 over negative 3. Because you're essentially doing 4 plus 0 over 0 minus 3. I know, it's hard. No. If I have like, those do not cancel. That's not a thing. Think with regular numbers. What if I had like 4 plus 5 over 5 plus 2? I don't know. That's 9 over 7, right? Not 4 over 2. Do you see it? You can only cancel things out when they're factors. They become insignificant because they essentially become 0, but they don't get canceled out. Okay. All right. 1 over huge. All right, let's look at F. Very similar to the one we did up above. So we have limit as x approaches, this time negative infinity. This is where we need our absolute value. Because think about when I plug this in, I've got 2 absolute value of negative infinity over 7 negative infinity. Not negative infinity. So let me rewrite the numerator. Do you agree that that would just be 2 infinity and this
I'm saying that 7 times the denominator.
would be negative? Yes. It'd be negative 2 over 7. Yes. Do we see it? Let's pause here for a second. There's a lot on this page. Okay, yay. We'll take what we can get, right? It's a start. How we doing back there, guys? All right, process for a second. Anybody got questions? Anybody? Okay, let's keep going. All right, we've already talked about horizontal asymptotes. We're going to just come down here to example 6. All right, I'm just asking you for horizontal asymptotes here. So guys, A, B, C, and D, try example 6 for me. I just want to know what the horizontal asymptote is on each one.
Sean, like,
All right, guys, letter A. What is your horizontal asymptote? Y equals what? 1/3. All right, guys, up here, letter B, horizontal asymptote. Y equals 0. That one's bottom heavy. Letter C. So this one's tricky. Depending on which end you are going to, you either get positive 3/5 or negative 3/5. Okay? If I thought about the limit as x approaches positive infinity, I'd be looking at 3x over 5, well, square root of 5. This should have a square root. Sorry, guys. Absolute value of x, which when I plug infinity in, they cancel out. You get 3/√5. When I go towards negative infinity, though, do you guys see the left end would be different? Okay.
So do you have to like?
You technically have both.
No, but can you take the root out of the denominator?
Oh, you can rationalize. You don't have to, though.
Out of
We are at the point in time where we suddenly now don't care about rationalizing anymore. It's very weird. We care for so long, and then we just don't care. So, yeah, you're there.
Oh yeah.
Okay, guys, D is also tricky. It has two different horizontal asymptotes. Guys, look up here. If I do x approaches negative infinity, this is like the one we just did that had huge over, 3 to the huge, all of that stuff. So this is like 3 to the negative infinity minus 4. I shouldn't have. Hold on. I'm not writing this right. Are you guys okay with -4/5 for that one? Does that make sense? Okay. Yeah, when it's positive infinity, it's different. Ugh, I cannot write this morning, guys. Sorry. So you get 3 to the infinity. Do you think the -4 even matters when I have 3 to the infinity?
So just make
Over 3 to the infinity from the denominator. What is 3 to the infinity over 3 to the infinity? 1. So you have two different horizontal asymptotes. One at -4/5. Squeeze in my y equals. What's the difference between what? Vertical asymptote is just where does your denominator equal 0? And then evaluating that limit, you're either like approaching the asymptote this way or approaching the asymptote this way. Yep. These are just all sorts of crazy graphs. And where are the ends of it going? Like where's the end behavior? Okay. All right, determine any asymptotes given this statement. This is our last one, guys. All right, limit as x approaches negative infinity equals 4, and the limit as x approaches 3 equals negative infinity. So you guys think about it for a minute. What sort of asymptotes do we have? Do we have a horizontal? Do we have a vertical? What do we know? We definitely have a vertical when it is approaching 3, so we can say we have a vertical asymptote at x equals 3. Yep. And think about this. It says as x approaches negative infinity, so the left end, your graph is approaching 4. So y equals 4 is one of your horizontal asymptotes. Okay? Okay, questions on any of that, guys? Anything at all? Okay. Some of these limits are just so simple and straightforward, and others you have to think so much about them. All right, we're gonna do a quiz. Yeah.